Hello, welcome to another DataMiner training video on Visio. Today I will guide you through advanced DCF in Visio. To start off, we will learn how to highlight a connection based on a filter shape. In our example, we have these 5 switches, which are connected to each other. To get more information on these connections, we can go to Properties and Connectivity. We can see our external connections, but on our internal connections, we have defined a filter property. To utilize now those filter properties to highlight this connection, we can go to our Visio and define a new shape called connection. In there, we can then input a value. The value which I input is my filter, and my filter can then choose between these 3 values. Note they are delimited by this icon here, which is important. If I click on OK, apply my changes, you can see now we have a drop-down selection. If I select VLAN 1, you can see the path highlighted. VLAN 2, and lastly VLAN 3. It's also an option to link this filter shape to a table, to a particular column. When you have an existing connectivity chain defined in a drawing, you can turn a shape into a filter for your drawn elements. Here you again see the example of our 5 switches which are connected to each other. And now we would like to create a shape for which we can then select one of these elements. To do so, we go to Visio and we define again a shape called connection. Now in this shape data, we will put the information value called connection elements. When we apply this and look back, we now get a drop-down for each element in our chain. And it will show how each element is then connected. There are several attributes which we can add to this particular parameter. To do so, add a pipe. And the first one that we're going to try is the item format. This will then list the items in the format that we now define. So I will say my item format is connectivity for, and then between round brackets, 0. This will then be replaced by my element. As we can see here. A second and last thing that we can define is the attribute for when no item is selected. Again, we separate with a pipe and then say no selection display equals nothing. Then you can see here now it says nothing. If you have defined a disabled connectivity on this particular shape, this shape will not appear in this list. If you have a drawing which you want to extend with elements to which your known elements connect to, but you don't want to draw them, you want to draw them dynamically, you can make use of the Unavailable element feature. If we go into Visio, we need to define 2 shapes. The first shape is another connection shape. So we already have our existing connection shape, which draw these connections between our drawn elements, so element A, B, and C. But here we now want to connect to the unavailable elements. So we need to define here unavailable elements connectivity. Secondly, we need to define a shape which will represent the elements which are unavailable. These elements, we want to also display the name of the element. So we define info name, put a wildcard inside, and we group this. On this group, we now add shape data. The first one being connection. And the type of connection is the unavailable element. This is the only one you need, but we can extend it with more shape datas. The first one being the expand direction, which can be vertical or horizontal. And we can also have a child margin, which is the space between two shapes. If we now save this and look back on our drawing, we can see now it has drawn a shape for switch E, C, and F. And you can see how they connect. If you were to modify our shape and say here we want to expand it horizontal, you can see here our drawing gets updated. We've seen the unavailable element feature, which connects elements which are not drawn on our drawing to elements which are drawn on the drawing. We can do the same with views with unavailable view connectivity. So we have our drawn elements, and one of these elements connects to an element which is in another view. If you want to dynamically represent that view to which that element which we have drawn connects to, you can use the unavailable view connectivity. To do so, we again need to draw two shapes. We go to our Visio drawing, and first of all, we again add a connection shape, which then represents the connection between the unavailable view element and also our known element. We need to put in here the unavailable views connectivity, and then we also need to draw a second shape which will represent our view. We give it the shape data connection with unavailable view as a value. We again can define a expand direction, a child margin, and also, because we have defined a star, we need to define info and the name. This will then resolve the asterisk inside to the name of the view. If we have a look to our Visio drawing, we can now see a shape has been drawn for our location C, because switch A connects to switch F, which can be seen here. And switch F is not drawn on this drawing, and it's inside location C, and therefore location C has been drawn here. DCF can be very powerful. In this example, we will use DCF to automatically link a certain shape to an element, based on the active path which will run through certain elements. Here we have element A and C. Element A connects to C, but in between it goes to another element. We don't want to automatically draw this ourselves. No, we want DCF to resolve it. So we go to our Visio drawing. Important here, we have drawn our switch A and switch C shape. We have put options highlight path on our page, and we have a connectivity shape defined. We will now add another shape for the element which is missing. We'll put an asterisk inside and then give it the following data. First of all, it will be an element. So we give it shape data element with an asterisk. The important one now here is resolve with DCF. This indicates that we want this element to automatically be resolved with DCF information. And we set this to true. Lastly, we add info name to it, so the element name will be displayed. Lastly, we need to connect our elements to each other, indicating that they connect to each other and that DCF should resolve it. If we now save this and take a look, we can see that automatically DCF has calculated that switch B is the one in between here. And this is how it connects to each other. It's possible to filter out DCF connections based on a connection property. When a connection is filtered out, it will not be used in any functionality inside of our drawing. These connection properties you can find by going to an element, going to general parameters, DataMiner connectivity framework, and then going to the connection properties table. In here, you can define a property with a certain value, which then links to a certain connection. In our drawing, we've made it possible that you can click on the line and can then see the property itself. This was done by adding the shape options, enable connection overview. If we now want to apply a filter to the shape, we add a new shape data called filter and put our filter in here. The filter we now go for is a connection property filter for property speed, and the speed property needs to be equal to 1 gigabit per second. If we apply this and take a look at our drawing, we can now see a lot of connections got filtered out, and only the ones with speed 1 gigabit per second remain. We can generate a DCF signal path from a particular element and interface without having to specify every single element along the way. To do so, we go to Visio and we need to define 3 shapes. The first one is our connection shape, so connection connectivity, which represent the connection lines which will be drawn between our elements. And next, we need to represent a parent shape. This parent shape will be the shape in which the shapes which will be dynamically generated will be displayed. So we will group this and give it the shape data signal path. And then you can choose here between forwards, backwards, or both. We'll now choose for both. This is then from your starting point to where it will go. Next, you define an element. This will be the starting element. We will choose for our switch A. Lastly, you need to define an interface. You can give a name of the interface or the ID. We will go for an ID. Now, inside of this group, we will now define a shape which will represent our element. So the element shape, we want it to display the information name of the element. So we'll do info name, put a star inside, and also we need to draw the interfaces. So therefore we add interface shape data and we set it to auto. So it will be automatically resolved. We'll put one for in and for out. Then we'll group this together. And on this shape, we then define the 3 shape data that we need. The first one being the element, because this shape will represent an element. Then the protocol shape data, because it's possible to define different shapes for each protocol it finds for an element along the way. So if you want to define those different shapes, fill in here then the name of the protocol and also the version which is used. If you don't want to define all different shapes, then you can just fill it in with default. Another attribute you can add for options is, for instance, the no duplicate. If it would find along the signal path, it will pass the same element multiple times. It will then not draw it multiple times, but just once. So we have our parent shape, which starts from switch A on this interface, and it will look for both directions. For each element it finds along the way, it will draw the shape and automatically resolve it to be the correct element. If we now would have a look inside of DataMiner, we can see it found the following path. It starts from this interface, in switch A, going to switch B, and then lastly going to switch C. If you modify it to another element, it will also automatically resolve if it finds a path it can follow. This wraps up our training for today. I hope you enjoyed learning about advanced DCF in Visio. We hope to see you again in one of our other online training videos. Thank you for watching, and remember, eventually everything connects.